Hello everyone, I am Shweta and welcome to my channel Analytics by Shweta. In today's video, we will learn about the basics of artificial intelligence. Now, what is artificial intelligence? Artificial intelligence is the ability of machines or computer systems to perform tasks that normally require human intelligence. So, in short, we can say it is a simulation of human intelligence. So, AI focuses on building systems that can do things we usually associate with human intelligence, like learning from experience, understanding languages, spotting patterns, understanding logic, making smart decisions, and much, much more. Now, what are the primary features of the AI technology? Now, the primary features of the AI technology are learning, reasoning, problem solving, perception, understanding language, adaptability. Now, let's delve into each of these. Now, by learning, we mean that AI systems improves over time by analyzing data. They recognize patterns, they will make predictions, and they get better as they get more and more examples. Now imagine teaching a photo app to recognize cats. At first, you show it thousands of pictures labeled cat and not cat. Then the AI starts looking for patterns like ears, whiskers, body shape. And over time, even if it sees a totally new cat photo, it can say, oh, that is a cat, because it has learned from all the examples it has seen before. Now let's look at reasoning. Now, AI can evaluate information, connect the dots, and make decisions based on logic, even when the solution is not obvious. So, for example, in a chess, an AI doesn't just memorize moves, it reasons about potential outcomes several steps ahead and chooses the most strategic decision. Now, let's look at problem solving. Now, problem solving is the ability of a system to analyze a situation, break it into smaller parts, explore different solutions, and select the most effective one. So AI doesn't just follow pre-written rules. It uses logic, it uses data and optimization techniques to find solutions even when the path isn't clear. Now imagine a person has a medical illness. It compares the symptoms to millions of past medical records. It will then cross-research it with latest research papers. It will eliminate unlikely conditions based on test results and then suggest the most probable diagnosis, possible complications, and even treatment options. Now we will look at perception. Now, perception is the ability to see, hear, or sense the environment just like humans do. So, AI systems with perception use inputs like images, videos, audio, sensor data, and then they apply computer techniques like computer vision, speech recognition, pattern detection. For example, a self driving car is a perfect showcase of AI's perception in action. A self driving car sees traffic lights, pedestrians, road signs through cameras and computer vision. It hears emergency sirens through audio recognition, and it feels distances and obstacles through radar sensors. So, other examples could be your face unlock on your phone, your voice assistants, your medical imaging using AI, your AI security cameras. Now let's look at understanding language. Now AI's ability to understand, interpret and generate human language, whether it is written text or spoken words, it's called as natural language processing. But it is more than just understanding words. It understands the words. What do we mean by that? So we mean that it grasps the meaning. It understands the syntax of the language. It detects the intent, emotion. It handles ambiguity. So AI allows us to speak in a way which is natural. That is, we are just speaking to another person. Now let's look at adaptability. Now AI's ability to adapt its behavior or strategies when faced with new data, changing environments and unexpected situations and without the need to be reprogrammed from scratch. So AI systems are flexible and capable of learning on the go. It just doesn't learn once and it stops. It keeps on evolving, it keeps on learning. So these are some of the primary features of AI technology. Now, what are the models of AI? The first model is the discriminative model. It is a model that learns to tell the difference between categories by focusing on how to separate them. The next is the generative model. It's an AI model that can learn the patterns in data and can create new data. And the last is the agentic model. It is an AI model that operates as an autonomous agent, capable of goal directed behavior, decision making, and interaction with its environment. We will look at each of this in detail. Now let's look at discriminative model. Discriminative model is an AI model that focuses on distinguishing between different classes. So it doesn't try to learn everything about the data. It only learns what features helps to separate one class from the other. So, for example, in an email, whether the email is a spam or not a spam, whether an image is a cat or a dog. So if we look at the probability, it is the probability of y given x, where x is the input features like, for example, email words, pixels in image, and the target class is whether it's a spam or not spam, or it's a cat or not a cat, or it's a cat or it's a dog. So given input x, which class does y belong to? So it is separating them, it is distinguishing them. So some of the use cases of discriminative model are spam detection, sentiment analysis, fraud detection, customer churn, handwriting recognition, face recognition. You can see there are so many cases, and these are just few of the cases. There are much more cases where you can use discriminative model. For example, in spam detection, as we earlier discussed, it is classifying emails as spam or not spam. In sentiment analysis, whether it's a positive, negative, or a neutral sentiment, identifying fraudulent transactions, image classification, that is, from images, we recognize what category of images they are. Speech recognition is converting speech to text. Medical diagnosis, you use medical images to identify diseases. Handwriting recognition, customer churn prediction, document classification, like whether they are legal documents, financial documents, educational documents. Object detection, it means detecting pedestrians, vehicles, traffic signs for self-driving cars. Product categorization can be categories like clothing, electronics, stationery, so classifying products. So these are some of the use cases. There are many more like malware detection, gender and age prediction, medical image segmentation. So you can use discriminative model in so many use cases. I have just given you a few, and let's proceed. Let's look at generative model. Now, what is a generative model? It's a type of AI model that unlearns the underlying distribution of the data so that it can generate new samples similar to the original data. So as the name suggests, generated, it generates data. So instead of just separating classes like spam, not spam, which we saw in a discriminative model, a generative model tries to understand how the data was created. They try to capture the structure of the data, and once they are trained, they can create new data points that look like the original data. So if it's trained on images of cats, it can generate new cat images. And if it is trained on text, it can write new text sentences. So how does the probability look like? So we say the joint probability of x and y, or p of x, where x is the input data like images, text, and audio, and y is the label. So generative models are creators and not just classifiers. It is important to learn the difference between generative and discriminative model. So let's look at the further examples. These are some of the use cases of generative model: text creation, code creation, image generation, video generation, music generation, voice synthesis, chatbots, marketing content, gaming content, voice cloning, education content, product prototyping. So it is just a few examples. By text generation, we mean that it can write articles, blogs, stories, social media posts. By code generation, we can write and debug new programming code. We can create new images, arts, illustration, and graphics. We can create realistic animated videos from text prompts. Through more music generation, we can create new music tracks. Through voice synthesis, we can create human like voices for narration, for audiobooks, for videos. Gaming content, we can create new games, we can clone the voice, we can create educational content. So, these are just some of the use cases of generative model. Let's proceed. These are some of the popular text generation, image generation, and audio and music generation tools, and also video generation tools like ChatGPT, Claude, Gemini, DeepSeek. For images, we have DALL-E, Midjourney, Leonardo AI, Stable Diffusion. For audio and music, we have Suno AI, Aviva, SoundRaw. For video generation, we have Sora, Runway, Pika Lab, Synthesia. So we have these are just few examples. There are so many more, and every day in the market, new and new AI tools are coming. So this list is continuously going to evolve over time. New features would be added in each of these tools. New tools will come in the market. So it has made our life so much easier. Now we will look at a brief introduction on the agentic model. Now, what is an agentic model? An agentic model is an AI system that acts like an agent. It observes its environment, it makes decisions, and takes action to achieve specific goals. It learns from feedback to improve over time. So it sees, it decides, it acts, and it learns. Some examples are a self driving car deciding when to apply a brake or accelerate, a game playing AI like AlphaGo planning the moves ahead to win. Now let's look at the probability. So the probability is pi of action A given state S. Now, some of the use cases of agentic model are autonomous systems, virtual assistants and AI agents, finance and trading, industrial automations, game playing simulations, space explorations, surveillance and security, supply chain and logistics, healthcare, and customer support and service bots. These are just some of the cases. As I already said, AI is evolving, so more and more cases, more and more benefits are coming each and every day. Now, let's look at the type of AI tools. First is the standalone AI tools. Now, standalone AI tools are independent applications with AI as the central technology. They are not tied to a specific ecosystem, and they can be accessed via a browser, desktop, or a mobile app. They are typically used independently and do not rely on being embedded on any other software. Now, the next is integrated AI. They are AI capabilities built into existing productivity platforms, creative software, or enterprise tools. So the user doesn't open a separate AI tool. So they stay in their usual workspace like Google Docs or Excel, and the AI works behind the scenes through commands. Now, the last is the customized AI. They are tools built or fine tuned for specific company or domain. They may be built in house or developed by a different vendor. They can be fine tuned on proprietary data, customized to understand business context, and they can be deeply integrated into your ATS, CRMs, ERPs, data lakes, and others. These are some examples of standalone AI tools: ChatGPT, Runway ML, Jasper AI, Descript, Synthesia. I have mentioned the categories and the description of each of this. So these are a few examples of standalone. These are a few examples of integrated AI tools like Microsoft Copilot, Google Workspace, Figma AI, Slack GPT, Canva AI, where they are integrated into a different platform. And these are some examples of customized AI tools. Like you have your legal assistant, healthcare assistant, insurance tool, retail tool, candidate experience bot, and onboarding assistant. So these are a few examples of customized AI tools. Let's look into AI and its subsets. So you have AI, you have machine learning within it, you have deep learning within it, you have Gen AI, and then you have LLMs. So AI refers to any technique that enables machines to mimic human language intelligence such as reasoning, learning, problem solving, and decision making. Now, what is machine learning? It allows computers to learn and make decisions without being explicitly programmed. It involves feeding data into algorithms to identify patterns and make predictions on new images. For example, image recognition, speech processing, language translation, recommender systems, and much, much more. Now, what is deep learning? Deep learning is a subset of machine learning that uses neural networks to learn complex patterns from large amount of data. So when we look at machine learning, all machine learning is AI, but not all AI is machine learning because AI has different subsets. Machine learning is one of the subset of AI. Deep learning is another subset of AI. And if we look at deep learning, then all deep learning is machine learning, but not all machine learning is deep learning. So one is a subset of the other. So if we look at it, neural networks are algorithms modeled after the human brain that helps machines learn by processing data through interconnected layers. Transformer model is a type of neural network architecture that excels at understanding sequences like text using attention mechanisms. Then we have generative AI, which creates new content based on patterns learned from training data. And then you have large language models. They are transformer based models which are trained on massive data sets to understand and generate human like language. Now, what are the types of machine learning language? You have supervised machine learning language, you have unsupervised machine learning language, you have semi supervised machine learning language, and you have reinforcement machine learning language. Let's look at each of them. Now, supervised machine learning is trained on label data, that is input output pairs. That is, it is used for predicting house prices and email detection span. These are some of the examples of supervised machine learning. Unsupervised machine learning works with unlabeled data to find hidden patterns or grouping. For example, customer segmentation, anomaly detection. Semi-supervised is a blend of both unsupervised and supervised model. For example, web content classification, text and document classification. And the last is reinforcement learning. It learns by interacting with the environment and receiving rewards or penalties, such as game playing AI or robotics. Let's look at each of this in detail. Now, as I said, supervised learning is a category of machine learning that uses labeled data sets to train algorithms to predict outcomes and recognize patterns. For example, we have given label data of various fruits. We have an algorithm, the algorithm processes, and then we have the output where each of this is given a label. For example, apple, mango, strawberry, banana, and orange. So the algorithm will analyze the features of each fruit. For example, it is round, it is red or green, it has smooth skin. Mango is oval shape, it is yellow or green. Banana is long and yellow. Orange is round, it's in orange color, it has a textured skin. And strawberry is small, red seeds on the surface and it has a green top. So it learns the patterns that differentiate each fruit. So when we give it new test data, the algorithm processes and it gives us the output that this is an apple, this is an orange, and this is a banana. In supervised learning, nature of problems, there are two types. One is classification. It deals with predicting categorical target variables, that is, classifying emails as spam or not spam, whether a patient is at a risk of heart disease or no. And the second is regression, that it deals with predicting continuous target variables. For example, predicting the price of a house based on its size, location, amenities, or forecasting the sales of a product. Some of the supervised learning algorithms are linear regression, logistic regression, decision trees, random forest, naive Bayes, neural networks, gradient boosting. Now, in unsupervised learning, it's a type of machine learning where the algorithm works with unlabeled data. Unlike supervised learning, there is no predefined output or right answers. It explores the data, finds structures, and groups and organizes it into meaningful ways. For example, if this is the input raw data, the algorithm first there's an interpretation of the data, then the algorithm processes the data, and then we have an output wherein you see the cars are separated segregatedly, the buses are separate, and the aeroplanes are separate. The four main applications of unsupervised learning are clustering, associate rule mining, anomaly detection, and dimensionality reduction. Clustering means grouping similar data points into clusters based on patterns in data. Dimensionality reduction, it reduces the number of features and retains important information. Anomaly detection is identifying usual points that deviate from the norm, that is, deviate significantly from the norm. And association rule mining, it finds relationships or co-occurrence between items in a data sets. Now, the examples of clustering are customer segmentation, image segmentation, document grouping, and these are some of the algorithms and the industry use cases. Now, for dimensionality reduction, we have data visualization, image compression, noise reduction. For anomaly detection, the examples are fraud detection, network intrusion detection, manufacturing defect detection. And for associate rule mining, we have market basket analysis, product recommendation, healthcare symptom analysis. Now, semi-supervised learning. It is a mix of both supervised and unsupervised learning. It learns from a small portion of labeled data and then uses the unlabeled data to improve generalization. For example, in medical image recognition, labeling all the images will cost a lot and it will take significant amount of time. So you train it on a portion of the images and then it uses the other portion to learn from the labeled images. For example, you out of 10,000 medical images, only 500 are labeled and 9,500 are unlabeled. So it learns from the labeled images to recognize patterns of the unlabeled information. These are two examples. For example, customer support email categorization. You label a certain portion of the emails and you unlabel the major portion of the emails. So only a small portion of the emails are labeled. So you train on 2000 emails, you predict categories for 2 lakh emails, and then you add predictions on the training set. And then you keep on retraining it for accuracy. Similarly, on the product sentiment analysis, you have a customer segments of various products. So you have 5,000 customer reviews which are labeled and 3 lakh customer reviews which are unlabeled. And then you use this to train a sentiment classifier. Let's look at reinforcement learning. Tell me and I forget, teach me and I may remember, involve me and I learn. Now, this is how exactly reinforcement learning works. It's a type of machine learning where an agent learns by interacting with an environment to achieve a goal. It tries the action, it sees the result, and it gradually learns the best strategies through trial and error. For example, a kid is playing with the dog and a ball. So it wants the dog to catch the ball. So the agent is the dog, the environment is the park, the ball, and yourself. The state is where the ball is and the dog's position. The action is running, jumping, waiting, and barking. And the rewards are treats, praise, and excitement if the dog catches the ball. So the dog learns that if he catches the ball, he will get a treat, he will get praise from the boy. So it learns. So it knows that if it catches the ball, it will get all this. And if it doesn't catch the ball, he won't get a treat, he won't get praise and excitement. Now, another example is in an e-commerce platform, how you give discounts to customers. So the agent is the AI system deciding the discount. The environment is the online store, the user behavior, and the product catalog. The state is the customer's data, the history, the cart size, the location, and the time. The action is, offering 0%, 5%, 10%, or no discount at all. And the reward is the final profit from the transaction or like a lifetime value. So it decides how much percent discount to give to the customer. Now let's look at deep learning. Now, deep learning is a subset of machine learning that leverages artificial neural network with multiple layers to analyze data and learn complex patterns. Now, the term deep refers to multiple layers in the neural network. So, more the layers, the deeper the network. Now, what is a neural network? It's a computational model inspired by how the brain works. So it is made up of layers of neurons, which is nodes that process information, and it's particularly good at recognizing patterns. Now let's look at a very simple example of neural networks, a very basic one. Now we have an image of an elephant and we have a group of people who have never seen an elephant, and we want them to recognize whether this is an elephant or no. So the first task we would give is assign each of these people a certain part of the body of the elephant. For example, for one person, we'll say you recognize the eyes. For the other, we say you recognize the ears. For one, we say you recognize the mouth, and so on. So, the first step is you have your people and you assign them a part of the body which they need to refer to. Then what these people will do is assign a weight from 0 to 1 on this part, saying that whether this is a part of an elephant or no. 0 meaning it is definitely not, 0.5 is maybe it's an elephant, and towards 1 means it's definitely an elephant. Then each of this will give a score to it. Then these scores will move further into the network to the next person. And then the next person would do is, for example, Ethan. Now Ethan is looking at only the face and Maria is looking at only the body. So Ethan will look at the ears, eyes, mouth, and trunk, and he gives these weights to it. Then he takes those values which each of these individual persons have given and he multiplies by it. So ears into 0.3 means 0.5 into 0.3. Eyes into 0.1, it means 0.6 into 0.1. And similarly for Maria, she looks at the legs and the tail. So legs into 0.8 is 0.7 into 0.8, and tail into 0.2 is 0.5 into 0.2. So you add the value, you add a bias, you add an activator, and then it goes to the next person, which is Janet. Now Janet once again adds a value to the face and to the body. So she's given 70% weightage to the face and 30% weightage to the body. So this value, which is 0.74, moves to the face, that is 0.74 into 0.7, and the body value, which is 0.66 into 0.3, and we get a value of 0.71, which means it's probably an elephant. Now how does it translate to a neural network? Let's see that. Now the image is converted. So it doesn't see an image how exactly as we see it. It converts it into numbers. So the layer 1 looks for simple patterns like edges, blobs, and lines. Is there a curve here? Is this part brighter than the next? The layer 2 will combine the patterns to find shapes. That is, this looks like a trunk, this looks like big ears. And the third layer recognizes the object parts as a whole. So now there can be multiple layers in a neural network. I have just shown you 3 layers, but in an actual neural network, there are many, many layers. Now let's look at forward propagation in deep learning. So forward propagation in deep learning is where the input data moves through the neural network from start to finish to produce an output or prediction. So it goes layer by layer, beginning at the input layer, then going through the hidden layers and ultimately ending at the outer layer. And each layer transforms the data based on the weights and the activation functions. Now, just as we have forward propagation, we have something called as backward propagation. So let's look into it. Now, in an example which we had seen of the elephant, what if we get the answer wrong that the image is not an elephant? Now, this feedback is sent backwards to each layer so that each can learn from their mistake and adjust their weights. So it says, let's go back through the network and figure out where we went wrong and what went wrong exactly. So the network moves from the output layer and goes back to the input, and it checks each neuron's contribution for the error. And then each neuron updates its weight and bias based on its role in the mistake. Now, since we have seen both machine learning and deep learning, let's look at the differences between the two. So, in terms of learning aspects, the machine learning learns patterns using statistical algorithms, and deep learning learns patterns using artificial neural networks. In data requirements, it performs well with smaller data sets, that is for machine learning, and for deep learning, it requires large volumes of data to perform effectively. Machine learning is best suited for simpler tasks with structured data, and deep learning is more suited for tasks with complex like voice recognition, image recognition, voice processing, language translation. The training time in machine learning is typically faster, whereas deep learning is layered, so it takes a little more time. Now, machine learning requires manual feature extraction and selection, and deep learning automatically extracts the features during training. Machine learning is more simpler and more interpretable, whereas deep learning is more complex. Machine learning runs efficiently on standard CPUs, whereas deep learning requires powerful GPUs or specialized hardware. Now let's take a look at generative AI. Generative AI refers to a class of artificial intelligence tool designed to generate new data that resembles existing data. Generative AI is trained on diverse data sets, which include text, images, audio, video, code, and different kinds of patterns for generating human-like content across various formats. For example, art and design, it can generate new images, paintings, logo designs. In text and writing, it can write emails, blogs, essays, stories. In audio and speech, it can, create music, video, podcast generation. It can write codes, it can debug codes. Now, generative AI is trained on diverse data sets. Now, these are some of the diverse data sets on which generative AI is trained on. It is trained on books, Wikipedia, social media, online forums, newspapers, handwritten notes, maps, software screenshots, images, security videos, call center recordings, podcast, interviews, radio shows, patents, academic documents, email transcripts, charts and graphs, and so much more. Now let's look at large language models. Large language models are a type of artificial intelligence that can understand and generate human language. They are trained on massive amounts of text from the internet, books, websites, articles, and they learn more and more patterns in language. They are the brains behind tools like ChatGPT, Google Gemini, Claude, Llama, Grok, and DeepSeek. These are some of the capabilities and examples of large language models. It can do text generation, it can do code assistance, it can do language translation, search and research, customer support, creative content, education aid, data interpretation, and much, much more. Let's look at the ethical concerns in AI. They are bias or discrimination, data privacy and consent, intellectual property, job displacement, AI privacy breach, consent in AI generated replicas, its malicious usage of the AI, its cultural inequity, its a generation of inappropriate content, and environmental impact. These are some of the ethical concerns in AI, and we have to look into these so that we can use AI more judiciously. So, in conclusion, AI is transforming how we live, work, and innovate every day, whether it's standalone tools, integrated solutions, or customized applications. AI is not about replacing humans, it's amplifying human intelligence, creativity, and potential. So, we need to treat AI not as a replacement, but as a powerful collaborator. The sooner we understand and adopt it, the better we'll navigate the future. So thank you for this video. If you like this video, please subscribe to my channel and hit the notification bell for more updates. Thank you for your time and have a nice day.